In this video, we'll be seeing about the factors influencing rate of the reaction in chemical kinetics. What are the factors? First factor we're going to see in this video is concentration. So as concentration decreases, that is reactant concentration, if it is decreasing, the rate will also decrease. Concentration is actually directly proportional to the rate. That is what rate law will state. Rate law is somewhat, it is when the rate of the reaction is given in terms of the concentration of the reactant is known as rate law. It can also be called as rate expression or rate equation. So rate expression states that rate of a reaction decreases with the passage of the time as the concentration of the reaction decreases, and similarly rate of the reaction will increase as the passage of time as the concentration of the reactants will increase. What does rate law states? Rate law states that it is an expression in which the reaction rate is given in terms of the molar concentration of the reactants raised to some power. That power, it is like this. Rate is directly proportional to the molar concentration raised to some power x and y. That x and y can be some stoichiometric coefficient or may not be a stoichiometric coefficient. Usually they are experimental value. They are not stoichiometric coefficient. Like for example here, to remove the proportionality constant, I have added the proportionality constant here k, which is a constant, and rate is also known as minus dr by dt, which is k, a to the power x, b to the power y. Here is an example for that. 2NO plus O2 gives 2NO2. To measure the rate of the reaction as a function of the initial concentration, we can either keep one of the concentration of the reactant constant and increase the other, or we can change the concentration of both the reactants also. So here in this example, first initial concentration of NO was 0.30. Oxygen was 0.30. I have not made any changes here. Then initial rate is somewhat like this. If I am doubling the initial concentration of one product alone, that is NO alone, if I am going to double, that is 0.660, keeping oxygen constant, I will get again double the value like this. And if I am going to keeping NO constant and changing the oxygen, doubling the oxygen, I will have some value. If I am going to double both the value, I will have some other value. So here it is obvious after looking at the result that when the concentration of NO is double, that is nitrogen if it is double, that is in second condition, and oxygen is kept constant, then initial rate has been increased with a factor of 4. That is, you can see initial rate 0.096 has been increased to 0.384. That is, it has been increased 4 times. Okay, if it is doubled. This indicates the rate depends upon the square of the concentration of NO. Square of concentration of NO, and concentration of NO is kept constant, and the concentration of oxygen is double, the rate is also double, indicating that the rate depends on the concentration of O2 to the first power. In third case, NO is constant and oxygen is double. In that case, it is the O2 is to the first power.